In this video, we're going to talk about the two special triangles that we will use over and over again in trigonometry. Both of them, we're going to be able to figure out what the sides have to be just based on standard geometry facts that you've learned in the past. The first one is the 45-45-90 right triangle, also called the isosceles. And isosceles, in case you've forgotten, it means that the two angles here in this triangle are the same. They're both 45 degrees. And one of the facts from geometry class is that when you have an isosceles triangle with two angles the same, those two sides are also going to be equal. Now, whatever one side of these is, the other one's going to be the same, so we might as well just call it 1 for now. And that means this is also 1. And then we're going to go ahead and use Pythagorean theorem to figure out what this hypotenuse is. We'll call it c. So a squared plus b squared is c squared. That gives c squared is equal to 2. So c is equal to square root of 2. So that means the 45-45-90 triangle has sides 1, 1, and square root of 2. And if you'd said, well, okay, what if that one side wasn't a 1? What if it was just some other number? And since you didn't tell me which number I'm talking about here, I'll just call it x. And if you do the algebra here, what you're going to get is c squared is 2x squared. When you square root that, you get square root of 2 times x. And so the generic 45-45-90 right triangle, whatever the two legs are, x and x, you can get the hypotenuse by just multiplying that value times square root of 2. So for example, if I told you I had a 45-45-90 right triangle, and one of the legs here was 5, that means the other leg is 5, and the hypotenuse is 5 times root 2. And that'll work for any 45-45-90 right triangle. The other one is the 30-60-90 right triangle. However, this is not an isosceles triangle, right? 30 and 60 are not the same angle measure. So we cannot use that fact that the two sides are equal. In fact, they're not going to be equal here. And really, there is no fact from geometry that says if one's 30, one's 60, then this will work out, other than the special triangle we're about to show here. But what we can do is we can draw a mirror copy of this triangle here. So this will also be 60 degrees, this will also be 30. And what you see then is that this bigger triangle now, including the mirror image, has 60 degrees, and the third side is going to be 30 plus 30 is also 60 degrees there, which means all three are 60 degrees. It's an equilateral triangle, and equilateral triangles all have the same sides. All three sides are equal. So what we'll do is we're going to say that this initial side right here, we're going to suppose that is 1. If that is 1, then by mirror image down here, this is also 1, which means the total side length of the red triangle is 2. That means each of these is 2. And then if we want to find this missing middle length, we can use Pythagorean theorem. We'll call this side b. 1 squared plus b squared is 2 squared. This time we're going to get b squared is 3. So b is going to be the square root of 3. And so the standard 30-60-90 right triangle, and please do excuse my poor drawing here, is going to have the shortest side of 1. The hypotenuse is always double of that. And the other side here is the smallest side 1 multiplied by square root of 3. So if we had another 30-60-90 right triangle, following the same idea of making one side x, but we're not going to do that this time. If I said the small side was 5 here, Then the hypotenuse is double that, so it's 10. And the other leg is root 3 times that, so 5 times root 3. And so using these two basic triangles, you're going to be able to solve quite a few problems in this beginning part of trigonometry. I want to point out that these only work if you have 45, 45, 90 or 30, 60, 90. If you have any other angles there, this whole process breaks down. And in fact, what you can think of is that the whole point of this course is to be able to take the same idea here for these two special triangles, but be able to still get the same type of answers when you have other angles. So it's not going to be, 1, 1, root 2. It's not going to be 1 square root 3, 2, like these two triangles are here. It's going to be some other numbers. But we are going to be spending the whole course learning the techniques for how to find those other numbers for what other angles you can go ahead and put in here. And it turns out by doing that, we're going to be able to solve a lot of other problems other than just triangles by applying this knowledge. So this is the beginning here. This is kind of the prototype for what this class is about. But you do want to know these two triangles before moving on to the more general situation.